So section 1.4, and there's some definitions here again in the bullet points. I'm not going to go over those. You can read those for yourself. I have not too much to add. Just a quick one on continuous and discrete. The example I like to give is a continuous variable. You could think of the size of your foot. Your foot starts at whatever length and then grows continuously. It doesn't go from immediately from, I don't know, 15 centimeters long to 16 centimeters long when you're at the appropriate age to have 15 or 16 centimeter long feet. It grows slowly, starts at 15 centimeters, and then it grows towards 16 centimeters, covering all the possible values in between at some point. But shoe size is a discrete variable. So you go from size 5 to size 5.5 to size 6. Your shoe size doesn't go continuously. There'll come a point where you decide, right, these shoes are too small, and you swap over from one to the other. Your feet are growing continuously, but shoe size is discrete data. And it's a nice one to remember because, remember, with discrete data, a lot of people think, well, discrete data has to be whole number values. It doesn't have to be whole number values, just has to be specific values leap straight from one to the next without covering all the numbers in between. So it often is whole number values. The example they're given here, number of girls in a family, it's going to be a whole number value, isn't it? When we're looking at frequency tables, you may be used to frequency tables which would look like this. So we would say from 0 to 5, we wouldn't write it as, so let's say time taken for something or other goes from 0 to 5 or from 5 minutes to 10 minutes. And you might be used to this sort of notation. And the idea with this was to say, well, if I'm measuring something between something that's time, it's continuous data, so I can take any value between, I don't know, between 0 minutes and then the maximum time for whatever this is that we're measuring. And what if I measure somebody as exactly 5 minutes? Well, do I put them in this category or this category? What I'm going to do is I'm going to put them into this category because this is an inclusive inequality and that is not an inclusive inequality. So I'm sure you're familiar with that idea, and it works very nicely as long as everybody's a mathematician. Now this notation, I'm sure if you can think back to the lesson where you first learnt that, somebody had to explain to you why we were using this notation and what this notation meant and what the purpose of it was. But in real life, nobody writes that notation. People would just say, 0 to 5, 5 to 10, and that sort of thing. So for this course, we're going to allow ourselves to go back to that sort of notation. If we've got something in time, and we're measuring it in the categories 0 to 5 minutes, 5 to 10 minutes, 10 to 15 minutes, we're going to allow ourselves to go back to this, because now we've got a good understanding, hopefully, of continuous data. If we've got something that happens between 0 minutes and 15 minutes, nobody's going to get exactly 5 minutes. If we can measure this as accurately as possible, somebody's just going to be just slightly over 5 minutes or slightly under 5 minutes. The chances of somebody hitting exactly 5 is pretty low. It is possible that we have the problem that the measurement that we get is exactly 5 minutes, 0 seconds, 0.00, as accurate as we can possibly measure it. But if we're taking a big enough sample, that's going to happen infrequently enough that if there's a bit of messing around with the data and they get shoved in one category or another, we're not going to worry about it too much. But if we are taking a lot of samples here, if we've got a lot of people in our sample, so we're doing good statistics because we need a big sample size, then we will have a problem using the mathematical notation, because who's going to collect this information? You can't necessarily have people collecting information and needing to explain all the mathematical notation to them first. That might be a bit of a pain. Who's going to read this information? We can't be displaying information with mathematical notation that not everybody understands. So with statistics, it is a useful tool. It's supposed to be used in everyday life. We need people to collect the information, and we need people to be able to interpret the information who aren't necessarily mathematicians. So we're going to go back to this sort of notation. Now that means that we can get things like this. In example 4, we've got the length of the 4 wings of butterflies measured in millimeters to the nearest millimeter. So to the nearest millimeter, it could be 30 or 31, 32 or 33, 30, well, it could be any of those numbers. Now, here's the problem. If to the nearest millimetre it's between 30 and 31, then that means that the actual boundaries for that class are 29.5 to 31.5, and the length, let's call it L, is within this group here, okay? So now when we read this in a table as the class, then because we are the mathematicians, we're the statisticians, we're doing the AS level or A level in maths, we should be able to interpret that and turn it into this boundary, and we know what that means as well, okay? So when you're looking at the tables, if you get a table like this that goes from 1.2 to 1.3, 1.3 to 1.4, we know how to interpret that one. If we get a table, let me see if I can find an example. Oh dear, we can't find an example, so I'll have to make one up. If you get a table that says 0 to 5, 5 to 10, 10 to 15, then the lower boundary here is 0, the upper boundary is 5, the class width is 5, that's no problem. But if we get a table that goes 0 to 4, 5 to 10, and so on, then 11 to 15, then when we look at this group here, we're interpreting that because this one stops at 4, this one starts at 5. We know that this group is actually 4.5 up to 10.5 with the inequalities and the inclusivity like that, okay? So watch out for those tables. Sometimes they'll be fine. You don't have to mess around with the lower bound and upper bound of the class. Sometimes they won't be fine, and you will have to take account of that. Section 1.5, large data set, very little to add here. Other than that, you need to get yourself used to the large data set. It will be available as a spreadsheet. All the information you need is in here, telling you what the large data set is, and I'm sure you've had plenty of information about where to find it and all that sort of thing. Not really any extra maths to tell you there, so I'm not going to talk about it very much more at all. Other than to say, just because I'm not going on about it at length doesn't mean you should just forget about it. You need to get yourself used to it. You need to know what information's in there. You need to know the sort of questions that they've asked about it in the past. You need to know what the columns look like, where there's missing information. So something recently, there was an exam board question. They gave us a measurement in knots and asked us to convert it to miles per hour. Now, that is completely a question where they're saying, have you looked at the large data set and do you know the conversion between knots and miles per hour? I think it's actually there in the large data set that you have in the exam. So you don't need to know it off by heart. You just need to know that the conversion is there somewhere. So you've played with the large data set long enough to know it well enough that you can answer that sort of question. If you've looked at it and you know that you can find that conversion, or you know that conversion in your head, then that's a mark for free, isn't it? There's not really any complicated maths there. That's about a GCSE grade 3 or 4 question, just converting. If they give you the conversion factor, converting from one to the other. It's very simple maths. It's just there are some marks on the exam for have you looked at it, are you used to it? So make sure you have and you are. And that, I think, takes us to the end of chapter 1.